Alright, I just wanted to capture some ideas I had that in order to write a new game, in order for others to write a new game, you have to allow them to code in a language that people know, and people know JavaScript. So allow writing JavaScript or TypeScript to create new games. And as a consequence of that, we need a secure way of executing other people's code. I'm recording. So as we're thinking about this, I got inspired by Mozilla Hubs has these MREs, and they are written in JavaScript, and they run on a remote server, and they connect to the room. So they kind of do the same thing. They have certain restrictions on what they can modify, but I think that what do you call these things? Maybe it's called a plugin, something that you write. I think that explains it well. People kind of know that plugin, it adds new functionality to an existing world. So we'll call them plugins, and they have maybe three parts. One is they subscribe to events in the main program, main loop program. Two, they do some logic. So this is conditions, look at current state, and then three, they're going to output some new state, new variables, and this can be broadcast to others. So this last part, okay, so this is where I think a plugin should do. And it's imperative, so this they can just use regular JavaScript, but this is their input, and then this is their output. The output can be declarative. So that means that this whole thing could be wrapped inside a web worker, and then the main thread will parse the outputted JSON declaration, and then can send that to a specific kind of gen server that is equipped to handle broadcasting specifically, but also storing variables and also sending out timed events. So that's what a plugin is. And the secure way of doing this, I think, would be we don't execute that on the main thread where people have access to the window, the DOM, the cookies. So we run user-defined extensions or plugins in a web worker. Now, I'm thinking I don't want to have one web worker for every kind of plugin, but maybe I can run all the plugins in a single web worker to cut down on the overhead of transmitting data. Because some plugins might need to receive the same message, and so you'll cut down on the transformation if you can just do it once. So we have some web worker boilerplate. And that might look something like this. So from the main thread, we'll do something like new worker load a custom URL with the slug ID of the space. And this thing will look at the manifest or some kind of definition of what's in the space and know which plugins to load. So this JS file is created dynamically and includes the plugins appropriate for the space. And how to write a plugin? So I think you write in TypeScript, and then we compile to JavaScript, and we can store in either S3 or the database. So we have that code, and it's just the text of the code is not going to execute by itself. This main thread, or sorry, this URL here will put them into the output. So and that'll be this part, the webworker boilerplate. So it will have definitions for each plugin, the JS classes, and then it will have an onMessage handler that is, how do you do this? Like this. That will react to the main thread, do some stuff, and then almost always give a post message with some payload back to the main thread. And one of the things that the main thread needs is, with a new worker, we need to send them a message to say, tell me what, like, get the subscription. So let subscriptions equal, well, it should be done this way, I think. We have to let worker equals a new worker, and then worker dot post message, like get subscriptions, and then the result of that would be a worker on message, or is it just on message here? On message, however it is. So you say, I want the subscription, to send it back, and when you're getting back the subscriptions, then for every type of signal that we're capturing, like keyboard inputs, mouse inputs, detection of intersections, whether something's being clicked on, pointed at, all that kind of stuff, if they have plugin definitions that are reading those, then we'll be capturing the appropriate ones and mapping them to a post message so that it'll get sent in here, and then in here it will instantiate each plugin and then call it. So each plugin will be a class that's instantiated with a constructor, but it has a method to get back what kind of subscriptions that they want to, and then they will get dispatched as the events occur. They'll get dispatched, they'll get fed into the plugins. Then you could make some decisions say you want to manipulate state, or you want to create some objects or remove some objects or move them, update them, change their color, put that kind of declaration back into some JSON object and pass it back into the main thread. And then the main thread will use WebSockets to send that back to the gen server, which will broadcast to every client that is connected. And then that client has an API that does not need the plugin, but knows how to understand that API in order to create things, to move things, to spin things, to play sounds, all that kind of stuff. So I think this might be a good way to extend arbitrary functionality to a base without needing to open the code of base functionality. All you need to do is write a new plugin, host this on the web somewhere, and pull the plugin as if it's a system into your space. And as long as you're subscribing to the things, subscribing to the events you want, and you can detect when your plugin is invoked by way of, maybe one of the subscription events has to be a tag added to something. Like a tag is added to a transform, which allows, and the tag is tic-tac-toe, you would, oh, this is where you want a game of tic-tac-toe. Then you know to create 9 boxes and you can have multiple games of tic-tac-toe because you can have 5 different transforms, and then all these transforms are tagged with tic-tac-toe, and then the plugin acts as a system that maintains the state of several games simultaneously. And it doesn't have any direct timers or variables. Variables are sent out in the object, they're given to the gen server, and the gen server updates the variables there and passes down all the updated variables to all the clients, because you got to update your neighbor's headset with the new variables. You can't just update yourself. And so I think this might be a good architecture, at least on a rough high level view. So I'll begin over the next couple days to see if I can transform this idea into some code. Okay.